Biography of Thomas Edison. Thomas Alva Edison, February 11, 1847, October 18, 1931, was an American inventor and businessman. While managing his company, Edison General Electric, prior to its merger with Thomson Houston Electric, he invented many devices that had a great impact on humanity around the world, such as the development of the phonograph, the motion picture camera, and the practical, long-lasting incandescent light bulb. He also developed several devices such as the electric power generator, mass communication, sound recording and moving pictures, and implemented the principle of mass production and organized science and large-scale teamwork to the invention process, establishing the Menlo Park Industrial Research Laboratory in 1876. Edison has 1,093 U.S. patents to his name, as well as numerous patents in France and Germany. His work in these advanced areas was an outgrowth of his early career as a telegraph operator. Edison developed a system for generating electric power and distributing it to homes, companies and factories, which led to a fundamental development in the world of modern industries. His first electric power plant was located on Pearl Street, Manhattan, New York, the Pearl Street Station. Edison established his first laboratory in Menlo Park, NJ, and later established a botanical laboratory in Fort Myers, Florida, in collaboration with businessmen Henry Ford and Harvey S. Firestone. Also established a laboratory in West Orange, New Jersey, and also established the world's first film studio, Black Maria, in the same place. Edison was married twice and had 6 children. He died in 1931 of complications from diabetes. The beginning of his life. Edison was born in Milan, Ohio, and raised in Port Huron, Michigan, and is of Dutch descent. He was the 7th and last child of Samuel Edison, 1804–1896, and Nancy Matthews Elliott, 1810–1871. His father had to flee Canada because of his participation in the failed Mackenzie Revolution in 1837. The young Edison was often absent-minded at school, where his teacher called him dissolute. Edison completed 3 months of formal schooling. Edison later recalled, "My mother made me, she was so sure of me. It was then that I felt that I had a purpose in my life, and someone I could not let down." His mother taught him at home. His reading of Parker's scholarly books on natural philosophy contributed greatly to his education. Edison suffered from hearing problems at an early age, and his deafness was attributed to repeated bouts of scarlet fever during childhood and untreated middle ear infections. During the middle of his career, Edison's hearing loss was said to have been caused by a train operator hitting him on the ears after his chemical laboratory caught fire in a boxcar and he, along with his apparatus and chemicals, were thrown from a train in Kimball Township, Michigan. In the last years of his life, Edison amended the story to say that the incident occurred when a train conductor helped him onto a train by lifting him by the ears. Edison's family moved to Port Huron, Michigan, in 1854 after work declined, and his life there was bittersweet. He sold candy and newspapers on trains running from Port Huron to Detroit, and also sold vegetables to supplement his income. He also states that he studied qualitative analysis and carried out chemical experiments on the train until an accident prevented further such work. Edison obtained the exclusive right to sell newspapers on the road and, with 4 assistants, launched a weekly publication called the Grand Trunk Herald. From this work, Edison launched many entrepreneurial ventures, and also discovered his talents as an entrepreneur. These talents eventually led to the creation of 14 companies, including General Electric, which remains one of the largest publicly traded companies in the world. His work with telegrams. Edison became a telegraph operator after saving 3-year-old Jimmy Mackenzie from a runaway train when the boy was stuck in a railroad, whereupon he met Jimmy's father, a station agent, Joe Mackenzie, in Mount Clemens, Michigan. Jimmy's father was so grateful to Edison that he trained him as a telegraph operator. Edison's first assignment away from Port Huron was to send a telegram at Stratford Junction, Ontario. In 1866, at the age of 19, Edison moved to Louisville, Kentucky. While working as a Western Union employee, he also worked at the Associated Press Bureau. Edison asked for the night shift, which allowed him plenty of time for 2 of his favorite hobbies, reading and experimenting. But his pastimes ultimately cost him his job. One night in 1867, he was tinkering with a lead-acid battery when sulfuric acid spilled onto the ground. Acid seeped between the floorboards under the boss's desk. Edison was fired the next morning. One of Edison's mentors during the early years of his telegraph work was fellow inventor Franklin Leonard Pope, who allowed poor young men to live and work in the basement of his home in Elizabeth, New Jersey. One of Edison's first inventions was related to the telegraph, and he received his first patent for an electric voice recorder, U.S. Patent number 90646, dated June 1, 1869. Early career. Thomas Edison began his career in Newark, New Jersey, where he invented the automatic repeater and other advanced telegraphic devices, but the invention that first gained him fame was in the year 1877, when he invented the phonograph. This feat was completely unexpected even by the general public for it to be considered magical. Edison became known as the Wizard of Menlo Park in New Jersey. The first phonograph was recorded on a tin cylinder, but it had poor sound quality and could only make the recordings a few times. Later the model was recreated using cardboard cylinders coated with wax by Alexander Graham Bell, Chichester Bell and Charles Sumner Tyner. This was one of the reasons that encouraged Thomas Edison to continue working on the complete phonograph. Menlo Park, 1876–1881. The establishment of the first industrial research laboratory in Menlo Park, New Jersey was Edison's major innovation. The laboratory was built with the money he made selling the quadruplex telegraph. Edison wasn't sure of the validity of his original plan after telegraphing it to sell it for $4,000 to $5,000, so he asked Western Union for a quote. He was surprised to hear of an offer of $10,000. Equivalent to $202,000 in 2010 dollars, and Edison gratefully accepted. The telegraph, quadruplex, was Edison's first major financial success, and Menlo Park became the first corporation established for the specific purpose of the continuous production and development of technological inventions. Most of the inventions produced there were legally attributed to Edison, although many employees carried out research and development under his direction. Edison instructed his staff to carry out his directives in conducting research, and he drove them hard to achieve results. In December 1879, a consultant electrical engineer named William Joseph Hammer began duties as a laboratory assistant to Edison, assisting him in experiments on the telephone, phonograph, electric railway, iron separator, incandescent electric lamp, and other cutting-edge inventions. However, Hammer's work was primarily on the electric light bulb, and he was responsible for the experiments and recordings on that device. In 1880, he was appointed chief engineer at the Edison Lamp Works. In its first year of operation, the station produced 50,000 light bulbs, led by general manager Francis Robbins Upton. According to Edison, Hammer was the pioneer of electric incandescent lighting. Nearly all of Edison's patents were protected for a period of 17 years and covered inventions or processes of electrical, mechanical and chemical nature. There were about a dozen patents on the design, which protect the decorative design for up to 14 years. As with most patents, his inventions were improvements on earlier industrial technologies. In contrast, the phonograph was patented for an unprecedented device that was described as the first device for recording and reproducing sounds. Edison did not invent the first light bulb, but he did invent the first commercially viable incandescent lamp. He was preceded by several inventors in the incandescent lamp industry, including Henry Woodward and Matthew Evans. Other inventors who made commercially impractical incandescent light bulbs were Humphrey Davy, James Bowman Lindsay, Moses Farmer, William Sawyer, Joseph Swan, and Henrik Ubel. Some of the disadvantages of these lamps are that they are very short-lived, have high production costs, and draw a lot of electric current, making it difficult to apply them on a large commercial scale. In 1878, Edison applied the term filament to the electronic component of current-carrying glowing wire, although inventor Joseph Swan had previously used the term. Swan built an incandescent electric lamp using long-term wires around the same time Edison did, but Swan's lamps lacked the high resistance required to be an effective part of an electric tool. Edison and his co-workers set out to make lamps that last longer. Joseph Swan was able to patent the incandescent lamp in Britain, although Edison made successful lamps for a while, but his patent application failed as it was incomplete. Edison was unable to raise the required capital in Britain, so he was forced to enter into a joint venture with Swan, known as a DISWAN. Swan acknowledged Edison's primacy and said, "Edison is more entitled than I am." His vision was considerably further than mine on this subject, and there were details which I did not foresee and which I could not understand until I saw his system. Edison produced a new concept in 1879, a high-resistance light bulb that would last for hundreds of hours. Prior to this, inventors had produced electric lighting in laboratory conditions dating back to the demonstration of the glowing wire by Alessandro Volta in the year 1800. However, Edison's focus was on commercial application, and he was able to sell the concept of long-lasting light bulbs to homes and businesses through mass production. He also created an integrated system for generating and distributing electricity. Within a decade, Edison's Menlo Park laboratory had expanded to occupy 2 city blocks. Edison wanted the laboratory to have a stock of almost every conceivable substance. A newspaper article published in 1887 revealed the seriousness of Edison's claim, by noting that the laboratory contained 8,000 kinds of chemicals, all kinds of manufactured nails, various sizes of needles, all kinds of filaments or wires, hairs of men, pigs, horses, cattle, rabbits, goats, camels, silk of all textures and different types of hooves, shark teeth, deer antlers, turtle shells, cork, resin, varnishes, oils, ostrich feathers, peacock tails, amber, rubber, and the list goes on. Edison displayed on his desk a sign that read a famous quote by Sir Joshua Reynolds, "There is no method to which man will not resort to avoiding the real business of thinking." This logo was posted in several locations and parts of the laboratory. Menlo Park is the first industrial laboratory concerned with creating knowledge, managing it, and then applying it to reality. He was dubbed the Wizard of Menlo Park by a newspaper reporter. Carbon transmitter for the phone. He worked as an employee to send telegrams at a railway station, which helped him in this work to invent the first telegraph machine to be sent automatically, to automatically record voter votes, but he did not find anyone to buy this device. Then he made improvements to the telegram writer, which was sold below its cost, and Edison has confined his thinking since that time to invent what people buy. Edison progressed in his work and moved to Boston and Massachusetts, and established his laboratory there in 1876 AD and invented an automatic telegraph machine that used one line to send many telegrams over one line. The electric light bulb. Building on earlier contributions from other inventors over a period of 3/4 of a century, Edison refined and developed the idea of the incandescent light, and is regarded by the general public as the inventor of the light bulb and a primary driver in the development of the infrastructure needed for electric power. After several experiments with platinum nanowires and other metals, Edison returned to carbon nanowires. The first successful test took place on October 22, 1879 and lasted 13.5 hours. Edison continued to improve on this design and on November 4, 1879 filed for U.S. patent number 223,898, granted January 27, 1880, for a light bulb using a wire of carbon or a strip of coiled and interconnected platinum wire. Although the patent contains several methods for making carbon wire including cotton, flax, wood splants, and papers wound in various ways, it was only several months after the patent was granted that Edison and his team discovered that charred bamboo wire could last more than 1,200 hours. The idea to use this raw material in particular arose for Edison from trying a few strands of bamboo fishing pole while relaxing on the shore of Battle Lake in present-day Wyoming, where he traveled with members of the scientific team so that they could clearly observe the total eclipse of the Sun of the Continental Divide on July 29, 1878. In 1878, Edison founded the Edison Electric Light Company in New York City with several financiers, including John Pierpont Morgan and members of the Vanderbilt family. Edison made the first public demonstration of the incandescent light bulb on December 31, 1879 in Menlo Park, and said at the time, "We will make electricity so cheap that only the rich will light candles." Louis Latimer joined the Edison Electric Light Company in 1884. Latimer patented in January 1881 his carbon manufacturing process, an improved method for producing carbon wires for light bulbs. Latimer has worked as an engineer, designer, and expert witness in the patent litigation of light bulbs. George Westinghouse bought Philip Dale's patent rights to a competing light bulb, 1882, for $25,000, forcing Edison's patent financiers to charge a reasonable price for the use of Edison's patent rights and lower the price of the light bulb. On October 8, 1883, the U.S. Patent Office ruled that Edison's patent was based on the work of William Sawyer and was therefore invalid. Litigation continued for about 6 years, until October 6, 1889, when the judge ruled Edison's claim to have developed electric light from carbon wires of high resistance. Edison cooperated with Joseph Swan to avoid a possible legal battle over a British patent granted a year ago, so they established a joint company they called Ediswan to manufacture and market this invention in Britain. The main theater in Brno, in what is now the Czech Republic, was the first public building in the world to use Edison's light bulbs, and the installations were supervised by Francis Gill, Edison's co-inventor of the lamp. A sculpture of 3 giant light bulbs was erected in Brno in front of the theater in September 2010. Electric force distribution. Edison patented the electricity distribution system in 1880, a key factor in capitalizing on the invention of the light bulb. On December 17, 1880, Edison founded the Edison Lighting Company. In 1882, the company built the first electric power plant owned by an investor in Pearl Street, New York. On September 4, 1882, Edison commissioned his electric power distribution system on Pearl Street, which provided 110 volts of direct current, DC, to 59 customers in Manhattan. In January 1882, Edison commissioned the first steam power plant at Holborn Bridge, London. The DC system provided the electrical supply for street lamps and private residences within a short distance of the station. On January 19, 1883, the first standardized incandescent electric lighting system went into use in Roselle, New Jersey. War of the Currents. Edison's real success, along with his friend Henry Ford's, lay in his ability to maximize profits by establishing mass production systems and intellectual property rights. George Westinghouse became an opponent of Edison because of Edison's promotion of the direct current, DC, system for the distribution of electrical energy instead of the alternating current, AC, system invented by Nikola Tesla and Westinghouse was promoting. Unlike direct current, alternating current can reach very high voltages with transformers, and send them through thinner, less expensive wires, thus directing distribution to users. In 1887, there were 121 Edison power stations in the United States supplying direct current electricity to customers. When direct current was discussed by the public, Edison launched a publicity campaign to convince people of the dangers of using alternating current. The problem with DC was that power plants could economically only deliver DC electricity to customers within a mile and a half, about 2.4 kilometers, of the generating station, which was only suitable for central business districts. Edison waged a war of currents to prevent the adoption of alternating current when Westinghouse proposed using high-voltage alternating current, which could supply electricity for hundreds of miles with marginal power loss, instead of direct current. The war against alternating current led him to participate in the development and promotion of the electric chair, using direct current, trying to convince him that direct current has more deadly capabilities than alternating current. Edison carried out a short but intense campaign to ban the use of alternating current or limit the voltage allowed for safety purposes. As part of this campaign, a number of Edison's employees publicly shocked animals to demonstrate the dangers of alternating current. Direct current has been replaced by alternating current in most cases for power generation and distribution, as it has contributed to improving the efficiency of power distribution and expanding its range. Despite its widespread use, direct current was eventually lost to distribution, and today is found mainly in high-voltage direct current, HVDC, transmission systems over long distances. Low-voltage DC electricity systems continued to be used in densely populated downtown areas for many years, but eventually many were replaced by the low-voltage AC distribution network. DC had the advantage of large storage batteries maintaining continuous power during short interruptions in the electricity supply from electric generators and transmission systems. Mirafic is equipped with rectifiers to convert low-voltage AC to low-voltage DC for fans, elevators and pumps. There were 1,600 direct current users in downtown New York City in 2005, but service was permanently discontinued on November 14, 2007. Most metro systems are still powered by DC power. Binoculars. Edison is credited with designing and producing the first commercially available telescope, a device that used X-rays to take radiographs. The technology was only able to capture very faint images until Edison discovered that calcium tungstate telescope screens produced clearer images than the barium cyanide screens originally used by Wilhelm Röntgen. The basic design of Edison's telescope is still used today, although Edison himself abandoned the project after losing his sight and injuring his assistant Clarence Daly. Daly was so enthusiastic about the telescope project that he made himself a human guinea pig and, in the process, was exposed to a toxic dose of radiation, and later died from radiation-related injuries. In 1903 Edison said, "Don't talk to me about X-rays, because I'm afraid of them." West Orange and Fort Myers, 1886 to 1931. Edison moved from Menlo Park after the death of Mary Stilwell and purchased the house known as Glenmont in 1886 as a wedding gift to Mina in Llewellyn Park, West Orange, New Jersey. In 1885, Thomas Edison purchased the property in Fort Myers, Florida, and built what was later called Seminole Lodge as a winter shelter. Edison and his wife spent many winters in Fort Myers, where Edison tried to find a local source of natural rubber. Henry Ford, founder of the Ford Motor Company, later lived within a few hundred feet of Edison's winter retreat in Fort Myers, Florida. Edison contributed technology to the automobile industry and they were friends until Edison's death. Edison joined the Civitan Club in Fort Myers in 1928. He was a strong believer in the organization, writing, "The Civitan Club accomplishes so much for the community, the state and the nation, it is certainly an honor to be included in its ranks." Edison was an active member of the club until his death, sometimes accompanying Henry Ford to club meetings. His later years. Edison was an active businessman until his later years. Just a few months before his death, he opened electric train and rail service between Hoboken, Montclair, Dover, and Gladstone in New Jersey. Electric power transmission systems for this service using direct current were championed by Edison. Edison was said to have been influenced by a popular diet in his later years. The only liquid he drank was half a liter of milk every 3 hours. It has also been said that he thought this diet would restore his health, but this is a questionable account. In 1930, 1 year before Edison's death, Mina said in an interview of him, eating the right foods is one of his main hobbies. She also said that, on one of his staged big science adventures, he would get up at 7 o'clock, eat breakfast at 8 o'clock, and was rarely home for lunch or dinner. Edison owned his hometown of Milan, Ohio in 1906. On his last visit in 1923, he was shocked to find his old house lit up with lanterns and candles. Thomas Edison died of complications from diabetes on October 18, 1931, at his home, Glenmont, in Llewellyn Park in West Orange, New Jersey, which he had bought in 1886 as a wedding gift for Mina, and was buried behind the house. Mina died in 1947. Marriage and children. On December 25, 1871, at the age of 24, Edison married the then 16-year-old Mary Stilwell, 1855 to 1884, whom he had met 2 months earlier, an employee of one of his shops, and they had 3 children. 1. Marion Estelle Edison, 1873 to 1965. 2. Thomas Alva Edison Jr., 1876 to 1935. 3. William Leslie Edison, 1878 to 1937, an inventor who graduated from the Sheffield Scientific School at Yale University in 1900. Plus Mary Edison died on August 9, 1884, at the age of 29, of unknown causes, possibly from a brain tumor or a morphine overdose. Doctors often prescribed morphine to women in those days to treat many ailments, and researchers believe that her symptoms seem to be related to morphine poisoning. On February 24, 1886, at the age of 39, Edison married for the second time in Akron, Ohio. His wife was 20-year-old Mina Miller, 1866 to 1947. She is the daughter of Lewis Miller, inventor and co-founder of the Chautauqua Institution, and benefactor to Methodist Charities. They also have 3 children. 1. Madeline Edison, 1888 to 1979, married John Eyre Sloan. 2. Charles Edison, 1890 to 1969, he took over the company after his father's death and was later elected governor of New Jersey. He then also became in charge of his father's experimental laboratories in West Orange. 3. Theodore Edison, 1898 to 1992, MIT Physics 1923, has more than 80 patents. Mina outlived Thomas Edison, dying August 24, 1947. Awards named after him. 1. The Edison Medal was established on February 11, 1904, by a group of friends and associates of Edison. 4 years later, the American Society of Electrical Engineers entered into an agreement with the group to offer the Medal Award as a major award. The first medal was awarded in 1909 to Elihu Thomson and awarded to Nikola Tesla in 1917. This medal is the oldest award presented in the field of electrical and electronics engineering. 2. In the Netherlands, the major music awards are named the Edison Prize after him. 3. Awarded the Thomas A. Edison has been patented on individual patents by the American Society of Mechanical Engineers since 2000. Awards 1. 1887, won the Matteucci Medal. 1890, he was elected a member of the Royal Swedish Academy of Sciences. 1889, won the John Scott Medal by the Philadelphia City Council. 1899, won the Edward Longstreth Medal by the Franklin Institute. 1908, won the John Fritz Medal from the Society of American Engineers. 1915, he won the Franklin Medal jointly with Heike Kamerlinghuis from the Franklin Institute for his contributions to discoveries that established industries and influenced human life. 1920, won the Naval Distinguished Service Medal by the United States Navy. 1923, the American Society of Electrical Engineers created the Edison Medal and it was the first recipient. 1927, he was elected to the National Academy of Sciences. 1928, won the Congressional Gold Medal. 2008, inducted into the New Jersey State Hall of Fame. 2010, awarded Grammy Technology Award. 2011, named one of the greats for the state of Florida by the Governor and Cabinet of the state of Florida.